Hi there, welcome back to Rethink Education in this Physics Grade 11 section. Today we're going to be looking at work and energy. So the very first thing that we have to come to terms with is what energy actually is. Energy is defined as the ability to do work, so let's have a look at work. Now, I struggled quite a bit to actually get a concrete definition for you guys, and believe me, I searched Google quite a bit, but I came up with this. Work is an activity involving mental or physical effort done in order to achieve a purpose or result. That's not so useful, right? But certainly it is pretty intuitive, and that is the thing about work. It is very intuitive, and I want you to remember that throughout the section. Think what makes sense, because that's really going to help you when we get to some of the more difficult questions. A little more searching got this definition. Work in physics is a measure of energy transfer that occurs when an object is moved over a distance by an external force, at least part of which is in the direction of the displacement. Now, that is a mouthful, but we're certainly on the money with this one. And so to analyze it and to actually make sense of it, we need to break it up into two different parts. First and foremost, it is the measure of energy transfer. This is hugely important, as work and energy are essentially the same things. Work is the measure of energy transfer, and energy is the ability to do work. The same things. Secondly, we get that work is the energy transfer that occurs when an object is moved over a distance by a force. So, essentially, work is what happens when a force moves an object over a distance. From that, we get work is equal to force times displacement. But there's also a sneaky little cos theta sitting in there, and that is the part which says the displacement and the force have to be in the same direction. Again, this makes some pretty good sense, because if you push an object in a certain direction, but it does something completely different to what you are trying to make it do, then you haven't actually really done any work in it at all. It's like your mother telling you to do your schoolwork and then you go and play PlayStation instead. Neither you nor your mother have actually done any work. So let's see what is happening. If you push a block with a force of 10 newtons forward so that it covers a displacement of 4 meters, then what is the work that you've done on the block? It must clearly be 4 times 10 times cos of 0, and therefore you do 40 units. Well, that's a good question. What is work actually measured in? You can use one of two units for work. Our definition tells us that it is force times displacement, which is newtons times meters, and therefore we get Newton meters. Alternatively, we know work is actually measured in is actually the same as energy, and therefore it can also be measured in joules. We therefore get the answer of 40 joules of work was done on the object. So we can use 40 joules or 40 Newton meters interchangeably, really, whichever one suits us. Okay, we are getting somewhere. The next concept to consider is work in a vertical direction. Again, let's look at a practical example. Do you think it'll take more work to lift a 16 kilogram dumbbell or a 1 kilogram dumbbell? Those gymmers around you will know quite well that the 16 kilogram one takes a lot more work. We can show this using our newfound knowledge as well. If we lift the 1 kilogram dumbbell to a height of 1 meter, we must have applied a force that is at least equal to the weight of the dumbbell, which you now know is 9.8 newtons down. We therefore apply this force in the same direction as the displacement, and we get 9.8 joules of energy. Remember, we could use Newton meters there interchangeably as well. If we do the same for the 16 kilogram dumbbell, we get 156.8 joules of energy. This clearly explains how some of your friends need the bigger muscles to lift the heavier weights. So the obvious question is this: which dumbbell will hurt more if you drop it on your foot? This may seem like a silly question, but it raises a very good point. The one that has more energy will hurt more. You know that this is the 16 kilogram dumbbell from common sense. Remember what I said earlier about that. But also, you know that the 16 kilogram dumbbell has a greater energy than the 1 kilogram dumbbell. You initially did work on the dumbbells and lifted them to a height of 1 meter. This work was measured in joules, and therefore you gave a certain amount of energy to the dumbbells. The heavier dumbbell took more work to lift to that height, and therefore it gained more energy in the transition. When you drop them and they hit your feet, then the one with the greater energy therefore hurt one hang of a lot more, and that was the 16 kilogram dumbbell. We therefore define the following quantity: potential energy. This is the energy that an object possesses due to its height above the ground. You know that it took work to get it there, so the formula for potential energy, which it can be shortened to EP, is, well, let's derive it. Work is equal to force times displacement times cos theta, but you know that potential energy, or EP, the displacement is actually vertically up. The force down is the weight of the object, and therefore we get EP, or potential energy, is equal to the force due to the weight of the object times by the height that it covers, and the force due to the weight can be broken up into the mass times the gravitational acceleration. So we get EP is equal to mgh. So before we end off, let's just run through a quick summary of what we've learned. Work is a scalar quantity and is defined as the force times the displacement in the direction of the force. Work and energy are the same things, and therefore work can be measured in Newton meters from the formula, or in joules, which is the same as energy. We know that a force that does not result in a displacement in that direction will produce no work from the cos theta term, and we know that work that acts directly up will give energy to the object that it moves up. This energy is called potential energy, and EP, or potential energy, is equal to mass times gravitational acceleration times the height above the ground. Right, so that concludes what we're going to be discussing today. But for the next video, we're going to be looking at the energy an object possesses due to its velocity, which is the kinetic energy of that object, and we'll also tackle the law of conservation of energy. I'll see you then, and remember to subscribe with Rethink Education. Cheers.